Lynn, do you have that mandate to? You have a mandate to record.
Yes, sir.
Okay. So let's go ahead. I was saying we have got. I think I don't know what happened to my typing here. I would have to see. There are various methods that you can use. I'm not sure which method it's what D2, single, centroid. I think we did. I think the complete one. Okay. Let me do this. So let me add the another method here. Right. Now, okay, I think the distance measure, let me change it to, which distance measure did I use throughout? Okay, I used the squared distance measure. Now, okay, after we had calculated the distance measure, right? So there are almost, how many of them? Five methods under hierarchical clustering. So hierarchical clustering, yes. We have got what is called the complete method. We have got what is called the word D2. We have got the single method. We have got the centroid method, right? And the median what method. So I think there are five of them, unless there are new developments online. You may check, especially when doing your assignment. Then you come up with those. So now we are looking at the distance measure. This is the distance that we have calculated from the data using the Euclidean distance. Now we want to apply the what? The H cluster, which is the right clustering on the distance, which is squared, right? The purpose of squaring distance is to make sure that it's positive, right? So if you square the distance, you apply this complete method. Oops, no. I think yeah, the error is coming from the labeling. Now I can run the what you call the dendrogram for for the complete method, right? So you see there are three clusters that I have selected based on probably the k-means, right? So that you may visualize. If you visualize, you see there is inconsistent. You are able to change that and see whether does it fit well the three clusters that I have considered. Probably they may not fit well from the what to call this, from the graph. So if you're going to look at the output that I have produced there, right, there is a cutoff point, which is the height, right? The height cuts the dendrograms into two, right? If you look at into three solid components, there is the first part, the second part, and the third part. I think the last part is well clustered, because if you look at the fusion of those trees towards the end, they're all similar, or they're all clustered, or they're all grouped. Compared to the first and the second one, there might be some complexity. You may look at this and then you probably may think four clusters are suitable for this state. But I think, or we can say two clusters, because looking at the fusion is towards the end. Let's try two clusters and see what happens with what the graph. So it's more of a try and error concept that you have to do. Right. So you look at this graph that I have now produced here. It shows you that there's some fusion towards the end. It produces what two clusters. Right. So probably you do for other methods the WAD2 method, and then you try to see the visualization. Doesn't it come up? Okay, here is supposed to be what rest dot what. If you apply that, it should give you a dendrogram, and then you see whether does it fit three clusters, right? So according to your interpretation or not, you would read online and see what makes sense when it comes to what to this. All right, you apply this again to you calculate the single distance measure, right? Then you have this. So you see those who are on here on the lecture, they can realize my mistakes. So it's HC dot single, distance for single. Then you can run that. You visualize again. You're able to tell us what's in that. Then you also apply the other distance measure, which is not the distance measure, the method for hierarchical, which is the centroid. And then you visualize it again. It says, okay, I think it's the labeling. HC dot CN. If you run that, it will give you a dendrogram. So all these are methods that you would come up with under the dendrogram. So you look at this, it's fun how it brings out the dendrograms. Use the median, and then you come up with the, it says, okay, it should be HCSC dot met. You run those. Sorry, I was now rushing to another one which is not yet. So let me clear the console. It says dot, okay. I have to run it again. Oh, it's not it's not a dot, it's an underscore. If you run that, it is to give you out a dendrogram. So now, based on the distance measures that we have used, probably different distance measures, they may produce different what? Dendrograms. So it would be nice for you, I'm sure Ara does it. You see, you have got how many plots? You have got 5 plots, right? You can do all these 5 plots on the same page, right? Where you can have a plot on centroid, a plot on complete method, a plot on what D, a plot on single, all the plots on the same what, on the same page, so that when you're interpreting the results, you interpret the results based on the what, on the plots on the same what figure or same diagram. We are sure that that's the power function. Try to look at that, how you can plot multiple graphs on a single one, on a single plot. If you do that, you can come up with those plots on the same plot, and then you will be perfect in terms of comparison, in terms of methods. So probably you may look at, select the distance measure that you think is good for you, and you apply that distance measure, and then yeah, you look at the arguments based on. So we need an argumentative approach when I come looking at this. So that's on it on hierarchical clustering. That's it on hierarchical what? Clustering. Then we look at the fuzzy clustering. Generalized is the partitioning clusters methods such as k-means and what, and the PAM, which is the medians. So it's a combination of k-means clustering and what, and the medians, by allowing an individual to be partially classified into more than one cluster. So this is a more recently type of what clustering, which is the fuzzy type of clustering. So fuzzy clustering, we will say, okay, let's use the fun clustering, and then we'll call our data, and then from the prompting that we have above, the number of clusters that we have obtained looking at k-means, we have obtained number 2 or 3, and based on PAM, we came up with 2. Based on hierarchical, it's also 2 or 3, right? So let's look at how does fuzz perform if you've got 2 number of clusters. All right. So first of all, we have to print the allocation. I'll allocate the number of clusters based on what, on fuzz. So you see, you've got 2 groups. You've assigned each observation to what, to a particular cluster. All right. So let's look at the visualization of the fuzz, and then we see what's on it. All right. And then let me print the graph, the visualization. So it's more of a descriptive. I'm sure this is almost similar to the silhouette, which is the PAM method. PAM method, I'm sure, is the similar plot like this. But on the basis of all this that we have above, so this is the first description part that we do. We first conduct k-means, we conduct the PAM, we conduct the hierarchical, we conduct the fuzz, right? But it's on descriptive, right? It's somehow like saying someone is aged 20, someone is aged 21. Those are descriptive figures, right? But in terms of the detailed information that there is a difference between those two ages, you need to have some validation of some sort. So based on the four methods that you've done, probably some of them they are prompting you to say in this data set you've got 2 number of clusters. Some they are prompting you to say you've got 3 number of clusters or 4 number of clusters. It depends on your perception. But at the end, you need to validate the clustering methods that you have. So looking at this now, we have got validation. So we've got internal validation and stability validation. So these are 2 validation measures that probably they combine all the clustering techniques to validate the number of clusters. So there are 3 main internal validation measures. We've got the DAN index, we've got the connectivity, we've got the silo width. So these are measures that are used with internal validation. So we seek to maximize the DAN index, the silo width, but however, we seek to minimize the connectivity. So we maximize the DAN and the silo width, we minimize the connectivity. So now we're looking at the C cluster, which is the validation, cluster validation, and then we're looking at 9 clusters, from 2 to 9 clusters, that's what you're looking at. So based on 2 to 9 clusters, let's pick hierarchical, let's pick k-means, let's pick PAM, let's pick fun, right? And then we validate internally. So if we do this, all right, yeah, there's some errors because of the fun, what called the fuzz, which is a fun function. But those are warnings. They may not hinder us, but I'm sure it's the issue of converging about the issue of fun algorithm is not converged in. I'm sure it's about the observation that we have. If you are going to deal with a lot of data set, fuzz will work well. I'm sure it's because they're dealing with few observation, yeah. So it's a warning, so it can run. So if you say somewhere in 10, right? So these are the results. That's why you see that fuzz is producing NAs. So we say we seek to maximize DAN, right? So let's look at DAN index, right? And we see at what point we look at k-means, we look at hierarchical, we look at PAM, we look at fuzz, right? For all the clusters and see where is it maximized from which particular method, right? You see here, we've got hierarchical, first one, right? So let's look at the DAN. Where is it maximized the most, right? Which is a higher number here. It's what? Is it 4 or 2? It's 2, right? So you look at the under hierarchical, it's considering 2 as the number of of clusters, because on that one it is maximized. So under hierarchical, you look at hierarchical, it gives us a DAN index. DAN index is giving us a 2. And then you look at connectivity now. Connectivity, sorry, let's start with silo width, which you want to maximize. So look at silo width again. The one that is maximized is at what? It's at 2, right? Then you look at connectivity, right? The one that is maximized is at what? So connectivity, the one that has been minimized is at which level? It's at k equals to 2, right? So you realize that hierarchical, where they use connectivity, DAN silo width, it's suggesting what? 2 is the optimum number of of clusters, right? Let's go again to k-means. We're looking at DAN index, right? We're looking at where it's maximized, right? It's what? It's a 2 number of clusters, right? And then silo width, where is maximized again? Is 2, right? I think, guys, I don't like communicating with Shona every time during the lessons. I'm sure your exams you're writing out in English, so I prefer to use international what you call the language that incorporates everyone into the lecture. So if you've got a question, just post a question in English. I'll not answer a question that has been posted in Shona. So here I'm looking at K-mean. So you're looking at the done index, right? You see which maximizes K that we have got K is equals to 2, and then you go to the silhouette. Again, it suggests K is equals what? To 2, and then connectivity, the one that minimizes it is K is equals to 2. You go to what? To PALM, you look at done, the one which maximizes it is K is equals to 2, and silhouette, the one that maximizes it's what? It's what? It's also 2. And then the one that minimizes the connectivity is what? It's K is equals to 2.
So you know that language down.
Who is that guy's name?
Anyway, now the one is not hard days.
Can you mute your mic? Tini, can you mute your mic? Tini, can you mute your mic? Tini, can you mute your mic?
Maybe some. Anyway. Mira, na ndichaona apo ndikuzonziso Tini, can you mute your winch? Mira.
Whenever you attend a lecture, try to mute your mic so that it doesn't affect the recordings. These are the ones that I represented. The plots that are here are the fuzzy clustering. I think there's someone who was asking a question. Who is that? Taffy. Say, can you show us the fuzzy clustering plots, please? These are the ones that you see on the right. Those are the fuzzy plots. So now I was looking at the PALM. The PALM is saying, okay, it's also suggesting 2 number of clusters. And then the fuzz is also suggesting what? Let's look at the fuzz. The one that maximizes the done, it's a K is equals to 2. And then the slow is the one that maximizes, it's what? K is equals to 2. And then connectivity, the one that minimizes, it's a K is equals to 2. So you realize all these methods, they suggest that K is equals to 2 is the optimum number of what? Of clusters. All right. So now, what's key in this section is to say, okay, suppose if it's an exam, right? I will not give you these optimal scores. All right. I will not give you what? The optimal scores. So you are supposed to come up with optimum number of clusters based on what I was doing here. Using this, that done index maximizes connectivity, minimizes, slow, maximizes. So now you know what has been done on the background. You know how the article was done, what K-means was done, what PALM was done, what fuzz was done. And you're expected to be able to tell us the story about these results to say, okay, deduce from the output what might be the likely number of clusters and which method do you suggest is probably the best method of of clustering. So it's not only that method, we have got other methods for validation. So there is a plot that you can use. Let's look at the plots. You know, it's good to learn. So now I think there are three plots, one for done, one for silhouette, one for connectivity. So if you say plot C to the next, you enter 1 and then you give it an enter, it gives you the all types of what clustering techniques, right? It gives you hierarchical, k-means, palm, fuzz, right? Then when it gives you all that, right? Remember we said connectivity is the one that what minimizes. So you see where it's minimum there at point k is equals to 2. It tells you that that's the optimal number of what clusters under validation. So you enter 2, right? Remember, done, we say it should what? Maximize. So you see it is maximum, it's what? It's k is equals to 2. Then you do the third plot, which is the last plot. Then it gives you what? The silhouette, which is another maximum, which is k is equals what? To 2. So it can be seen that the hierarchical clustering with 2 clusters performs the best. In each case, connectivity and silhouette method, regardless of the clustering algorithm, the optimum number of clusters seems to be 2 using 3 measures. So these are validations. It's required in an analysis to be able to what? To validate. So we have got stability measures. That's another way of validation. Like we talked about internal. We're not looking at stability measures. So we've got the average proportion of non-overlapping. We've got average distance. We've got average distance between the means. We've got the figure of the merit, which is FOM. So these are stability measures. So we want to assess those clustering, whether how stable are they based on our results. So I think I did the same command twice, so I can remove that. So all the measures, the stability measures, we seek to what? To minimize them. All right. So we apply stability. These errors, it's because of fun. I'm sure because of the few data points. So if you, what happens? Optimal score, what is it say? Okay, I think for the optimal, let's try to remove the fuzz and see what happens. Because it's giving us an error. Right. I'm sure, yeah, fuzz has got some problem there on our data set because of its flexibility. It's not that flexible as in compared to other methods. So if you look at the scores here, it gives you the suggestion to say, okay, APN and AD and ADM and FOM, right? They minimize the score, right? And the method that are probably prompted to say that the best is hierarchical with 2 number of clusters, right? And also the PALM with 9 number of clusters. But now, based on the results that we have, so you would need to have to come up with a conclusion to say PALM yields now suggesting 9 number of clusters, but on the internal validation, it never suggested what? 9 clusters. So you need to have an argumentative skill and justification skills to say how many how many number of of clusters do we have, right? So we need to have an argument based on various methods. So we are doing this so that we can have a better picture of the number of clusters that we have in our data, right? Suppose maybe let's say I want to, let me see what I can do. I want to see something. Suppose we've agreed that there are 2 number of clusters. So let's look at some relationship between the number of clusters that we've obtained and the classification. Remember, initially our data with what? With classification to say which species does it belong to. I'm sure if you can use Glimpse, you can visualize better. So I think Glimpse requires lab multiplier. What's the spelling of multiplier? Multiplier. So I've used multiplier. I want to use Glimpse. Yeah, I think it also gives you the structure. Okay, let me use levels. I want to look at the how many classes do we have within our data in terms of the species data. It seems we've got, yeah, if you use we're left with 10 minutes, we'll be done. So it seems as we've got 3 classes that we have, right? In terms of our species, but our data now suggests that we have got 2 classes. So we would have to find out, okay, which particular species is not really represented by what? By our data, right? We would have to find that. So let's look at this. Okay, before I look at that, let's plot and see our plots. All right, so you've got 4 plots. So you say 1 enter, you get that one for star APN, right? And then 2, you get one for AD. Then 3 enter, you get one for what? ADM. Then 4, you get another, which is FOM. So you get all the plots by saying plot the object name of stability. So now I want to look at the data that you have, and probably we look at, sorry, what should I have done? Okay, it's okay. So my data $, what, or iris $, let me say iris because I want to pick the species. Iris, yes, $ species, and then now let me see k-means. How many number of clusters did I use the k-means? Okay, it was 2. Let me rerun so that I'm sure that those are 2 clusters. So I say k-means $ cluster. Right, let me see if it gives me a table. Yes. So you see what's the table coming out there? It gives us 2 clusters that we have selected, and it tells us that we have got Setosa, which is in the first class, what to call cluster. Then Versicolor, which is in the second cluster, and Virginica in the second cluster. All right. Can somebody tell me what does it mean? What does this data mean? After we've obtained the number of clusters that we have here, right? What is that table telling us? Because according to the classification of their data, these people, they classified as we've got 3 clusters, right? But now when I'm doing our analysis, we realize that there are 2 clusters. So what does it mean from the results that we have there? I need your response. Let me mute my mic so that you guys.
I'm not sure, but I'm going to try from same thing. I think the number 1 shows us that Setosa is 50 variables under cluster 1. Since we have 2 clusters, 1 and 2, then it has 0 falling under k equals to 2. Same with Viscola. It has 0 under k equals to 1 and 50 under k equals to 2. Then the last one, Virginica, it has 0 under k equals to 1 and 50 under k equals to 2. Then if we add, we have 150 variables, which is the total of all variables that you had.
But all that has been said by Tino, what does it imply? Kevin, go ahead.
I think since Setosa has got no numbers in the second class, I think those two in the second class, that is Vescala and Virginica, I think they've got the same characteristics. So we can group them in the same class. Then Setosa, I think we can take it as a distinct class from these two ones. I think that's what I think, sir.
Very brilliant, Kevin, very brilliant. You know, sometimes you may say a person, suppose you're in the health profession, right? And then you say this person has got HIV, while that person doesn't have HIV, right? Or you may say this person is or an object or an item in business, it's a defective, while it's a non-defective, right? But based on the characteristics, we can come up with the word a grouping. So there are a lot of situations that these things happen. We have got people at work, they do their groupings, right? And say, okay, this is in group A, B, C, D. But after doing some exploration and realize, no, the grouping doesn't suggest that we have got 3 classes here. We probably have got 2 classes. So that I'm sure there is some characteristics features that you have said between versicolor and Virginica that brings them what together. And you will see that the accuracy, it becomes accurate. So based on the clustering technique, we're saying the number of species that we have is what? 2, based on our data. So this is the real learning of it. This is aspect of it. All right. So you have to look at this clustering that way. So I'm sure with the data that we have now, they've got more work to do. I think the 2 people had raised their hand. I'm not sure where they. Brendan, you can go ahead. Brendan, no? You're left with 3 minutes, guys. So.
So today I've been experiencing bad trip. I wasn't able to follow the lesson.
Yeah, I'm sure Atinashe is recording, so he'll give you the recording. Or Fadzai Chitengu, she's got a question. Go ahead, Fadzai.
I wanted to ask on our data on the species. Can we access our data saying that the data is non-overlapping for Setosa and the other 2 species? And then for the other 2 species, that's Vescala and Virginica, they're overlapping. Can we actually assess our data saying that after saying the 2 have characteristics, the last 2 have similar characteristics compared to the first one? Can we put the idea of overlapping and non-overlapping, or it's good as it is?
No, I think the overlapping, it comes to the analyst who classified Setosa, Versicolor and Virginica. Those people who classified probably they didn't look at the characteristics in detail this way. Now, yourself, you're looking at this and saying, yes, I think in terms of our clustering, there was none overlapping. So I think let's go back to clustering and then you see what it means, Fadzai, right? What they are suggesting, them who captured the information about this iris data. Remember, we suggested k is equals to 3 when we didn't k means clustering, right? let me change here, and then you see the overlapping part, which brings it to show that there is some similar characteristics between, you probably can identify now which what do you call, which sets are overlapping, right? So I've assigned the clusters. Let's visualize it. So you see the k-means that I've done, right? There's one that is distinct to this one, right? That's setosa, right? And they have classified them. We have considered k is equals to 3, and this number of clusters now they are overlapping, right? So the overlapping part of it shows that there's some similarity in terms of the what you call, in terms of the species that we have, the vesicola and the virginica. So we'll try to avoid such situations and probably say, okay, this belongs to that and this doesn't belong to this. We did our clustering analysis, right, based on k-means, the palm, the radical, and the fuzz, and all these were suggesting what, 2 number of clusters. We did our validation, right? We did our stability validation, right? It confirmed